Hey guys, welcome to another video. So we are going to do this problem which is called word search problem. Yeah, let's try to solve this a problem which is a medium level problem. Here we have a word and we have to find whether the word is in this board or not. We have to find that. So if you see this problem, I first thought is came in my brain is that to move into like rows whether it is there or not, we have to like if you want to see whether it's true or false, you have to just move on like here I if you see it matches and move to rows. If there is element in the rows, you'll find this element if it is in the rows, or if it is not in the row, then we have to find its column whether it is found in its column. If it is not, return false because it is not found. Let's if you see here a b rows found, column rows found, then neither row neither column is found. Okay, and you have to change it to like already found. So you have to have consist only lowercase and uppercase English letters. Okay, okay, English letters. Okay, yeah, to return only true or false. So if you have already moved to and we do not want to go back, so we can return, we can mark is as already solved. If not, then again go back and here you go. That's what we are gonna, and backtracking by, I think we're gonna do it by backtracking or something. It's my first thought of doing of solving this problem. Yeah, so what do you need? We need a word, we need a board, we need also index. Yeah, so I think we're gonna need a solve function where we're gonna need indexes. Yeah, so return solve board word and index that says 0. Need row and column also. Column. Okay. If word exists. Now bool we need these things. Mm. I think I know how to solve this problem. Wait. Okay, I haven't. Sorry. Yeah. Now it is showing, I think. See? Yeah, I think. But okay, wait. I'll make it bigger. Yeah, now it is showing. Let us make this function bool. Hmm. You see, problem. We have mn in row and column. Okay, yeah. So we will start from 0, 0 to move to zeros found. Yeah. Yeah. So what we wanna do is that we are gonna find the first element, because first element should require us. Okay, we require first element, and then what we're going to do, we need index also. Yeah, yeah. We need, yeah, first. Then we will just backtrack in all four directions, because it is gonna we gonna found it. Obviously, if we are in the middle, we have four directions to move. We can go down, we can do left, right, we can go left, we can also go up if it is not visited. It is like a rat in a maze problem, similar to that only. We find all the letters adjacent. So at the end, if we found, obviously if we have found the element, we have to return true. Otherwise we have to return false, or try to find other cases where it can be found. The edge cases is that when we should stop, like, yeah, when we should stop. Yeah, we if we have already reached the mn, yeah, mn, m minus 1, n minus 1, if we have already reached end of the bound. Also, and um and also the, if you have already if the letter is not found in the matrix, we can say, or either of these, because you might reach the boundary when you haven't found the letter, or it may be, you can say also that the letter is not found in the boundary, sorry, what do you call, the matrix. And also there is a uh, uh, when we say it is found, like when we say it is a true, when we should return true, when we have already traversed the world. Yeah, yeah, visited. We need a visited, because, or we can on change it on the board only. Yeah, it is solvable though. So we need mn also, boards row and column. We need index to traverse the word. So we, for at first we'll find what? We'll find the word in the board. First word should be needed. We need, and then search it. If you can search it, then return true. out of the all the cases. If you can't find it, like let's see, let's say you have called the function, can't find it. Then again it will work on the again it will start to find the other, like in there is more elements where you can find the first element and then backtrack into all four directions. Yeah, so next, all the elements are found, then we just return true, obviously. How we're gonna check whether we have reached the boundary? When? If row is less than 0 or column is less than 0 or row is m, column is n, or board of row column not equal word. Next it is not found. What is this? Don't know, man. Okay. Yeah, if we have like already visited or something. So three things, like boundary, inside boundary. If it is outside boundary, return false. It's the edge cases we are thinking of. Then it's a base case we can also say. And it already visited. If we have you were moving to the already visited, then should not. We have to mark it something. We have to mark it with something that we have already visited by space or something. And also if we could not find the word, yeah, if we could not find the word. To prevent it, we just mark that like visited with some symbol. Then check the top given by this, check the right. All these are hypotheses. At last, um, obviously we have passed it by reference, so we had to backtrack also. If either of them is true, like we have found it, so we have to return that. Pretty simple, pretty simple. Yeah, yeah. This case, obviously. Yep, yep. I think we can solve this problem pretty simply. Let us solve it. So what are you gonna do? We need more things here. If you see, we need more things. Let's try to code it again. So what do you need? We need um we need m, which is number of rows, that is our board dot size, let's say. N board number of columns, let's say. We need index, we'll make it. We need find the first element. Okay, finding the first element, and then we have to traverse whether it is true or false. So first element is needed. So how to forget the first element? We are gonna uh like word of 0, word of index. Get the first element, and then we have to just call the whether it exists or not. If board of ij equals word of index, we need index also. Hmm. Yeah, yeah. If board I j word of I, and also if like search next element. Okay, search next element. Yeah, with should have the board. Oh shit, what did I do? Board word index mn um board mn index. And do you need anything more? I don't think so. Let's say if it is on bool function, obviously, then return true. If either of the cases we didn't find anything, return false. I think this is what it is. Yeah, we also need rows and columns of that first index. We also need the rows and columns of the first index. Okay, now bool search next element. Int row, int column, int index, int m int n. All these things are required. Yeah. Yep. 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 So what you're gonna do is that mm, thinking of the hypothesis IBH method that mm, let's say bool top. We're gonna like we have found element and we have to see top element of all check functions, all check functions. Search, like search next. I think it is like this. Oh shit. Yeah. So board word. Let's say if the top function founds the top element, whether it is found or not. So what? Row minus one, column is same. If it is found, then index plus one and n is though there only. Similarly, the top, bottom, and four directions. Yeah. So top, bottom. What? I didn't. Top, bottom. That's the left. That's the right. If you move to the bottom, row plus one. If you move to the left, left. So I think row is same. Column is minus one, obviously. And we move to the right, column plus one. And these things will give us the search true or false. Yeah. So that's the best case. If index is equal to the word dot size, that means true. All elements is found and we have to return true. Pretty simple. Now, let us think of the edge cases of what is not possible. What is not, like, when it should return false. We have to think also. Yeah, when it return false, when it should return false. If you think of that, then if it go away from the boundary, let's say row like less than 0 or column less than 0 or row is equal to m or column is equal to n. Yeah. Or we can say that word like board of row and column not equals to um our board of row column not equals to the uh, word of index. That's why you increase the I plus one. Or um board of row column equal to already visited. Let's say we're pointing it with space. Return false. So visited to um to make visited, what you gonna do is that we gonna make it like we have to make char, let's say C equals board of row and column and board of row and column is equal to, so we are making this thing like already visited, if already visited. Okay, after backtracking to backtrack also, after doing this on board of row and column was to again we make it backtrack it. Okay, we are making like all these things are in this in the board only. Then we just return either of them is true, we can return that. I think so. Okay, so there are some errors showing. Error expression not eligible, not assignable if what using yeah, okay, got you though. Yeah. Mm, pretty simple though. Yeah, it is solvable. So let us sum up this problem. What you have done. Let us sum up this problem. Yeah. So in this problem, what you have done, let us see the time complexity. What's the time of m into n, 4 of length. Okay. So see the time complexity also. Let us think. Let us see what we have done. So in this problem, what we have done is that what do we need first problem statement. Let us again read and understand what the problem statement says. The problem statement says that we have a m into n board and we want a word that is a b c d e. Whether it is found or not, we have to just return true or false. We have 4 directions, whether we can go up, we can go left, we can go right, we can go down. All these things are done. So we have to search, obviously. So yeah, and it should be in continuous, like all these things are continuous, should be continuous, otherwise we have to return false. Okay, so what we done, we have at first we have made the m and n index, all these things we need only. So we have at first we just tried to find whether we can find the element or not. Let's say m into n, so big of m into n here, we can say, we can see that big of m into n here, it is showing 2 loops are moving, so big of m into n. Now we are seeing whether we can find the element in the which is word of index. Yeah, and whether it is found or not, we are just checking. Yep, we just want to check whether it is found or not. I make use this to use this type of things because it is helpful. Make it at first because it is helpful for you. Like it is the little things you do what makes a code beautiful and understandable. Search next, these things helps. So try to find the first element. If you have tried to find, if you have found the first element from the word of zero, yeah, we have found it. So we try to find the other elements also. Try to find. So if search next is true, if it returns true, like all the elements are found. Next, all the elements are found. Then we just return true, else return false. If we can't find it, it should return true. Can we will search it. Otherwise, it should return false. So this is the main function which is required to understand. That is search next. That should search next, like next. See, we are finding next. When it is true, let us think of that. If we think of that, then when it reaches the end, like word has ended, like all the words are searched, that means we have to return true. Pretty simple. Does this make sense? Yeah. Then if you think of when it should return false also. It should return true when it should return false because we are dealing with bool function. So it should return false when our we are out of boundary, let's say, or we haven't found the element, or we can say that it is already visited. So to make it visited, what do you have done? We make it um like we have taken the word because it is required to backtrack also. So we just taken the word and make it dot, that is visited. Or let's say v, you can do anything. I just make it dot. Yep. Does it make sense? Yes. Then just this is the hypothesis. This will do it by itself. Yes. Hypo. That it would, like top function will give us the search function for it will find for the search for top, whether it is found in top or not. It will return false if it not, it is already visited, or if the word is not found, if it is already visited, or it is um like it is out of boundary. In all the cases, it will return false. Then again it will come to bottom. It will check for bottom. If it is found, then all good. It will return true. No. It is found, then all good. All good. Then again you'll find from top to, if it is found in the left, then again all the elements return. From here it will return true. Not found, return false. Does this make sense? And if it is already visited, it would return it as dot. Does this make sense? Yep. So, yep. And after um all these things, we have to make backtrack also. Searching all this, it would return from here only or here only. Doesn't. After finding all this, either of them doesn't return true. And then backtracked it. I think it is not required. Let's see. Uh, non-void function should return something. Yeah. Mm-hmm. This is good. This is good. But at last you have to return something. Yeah. Because it is non-void. So you have to return one or return row or return something. Something you should return. The top or the false. Either of them is true. You have to return true. Does this make sense? Yep. So if you see big of m into n, and this function is running for what? Like we have four choices. So 4 to the power, let's say it is running for, I think n is the it's running for n. So the time complexity would be big of m into n into 4 to the power, let's say L. L is the length of the word, because we have four choices for each and every worst case scenario. There is four choices of each and every like top, bottom, left, right, all these choices. Yep, we know that it is visited, it can be done, like four choices is there, four choices. We know there is three choices only because um we can't visit, but we can think of four choices in the worst case. And the time complexity and the space complexity is our board, and word is given though. Space, are we using any space more than that? I don't think so. I don't think so. We're not using anything. So the recursive call auxiliary space, we can say recursive call, which is big of n. If we passed word also as reference, then what would happen? Does the space complexity changes? What is 11? Yeah, it does. It does make a big difference. Here also space complexity, space improves, we can say, and the space complexity is not required that much of. So hope you like this video, and like, share, subscribe, and uh, this is for now, and hope you like this one, and I will be posting more videos on this, and this is for now. Hope.